So can you please help me in sharing that PPT? I'm not able to share it actually. Dr. Asad, can you please help me in sharing the PPT?
Yeah. Komal, give me 1 minute.
Okay, sir.
Yes, Komal, you can start.
Yes, sir. Good morning, everyone. Myself, Komal Vashisht. I am a research scholar at Faculty of Management and Commerce, Baba Masnath University, Haryana. I welcome you all in today's session 2 of second day of Structural Equation Modeling and Artificial Neural Network in Management Research, ATAL FDP. Today's second session is on measurement model and path analysis on AMOS, and our guest speaker for this session is Dr. Vikas Kumar. Dr. Vikas Kumar is presently working as an assistant professor in the Department of Marketing Management at IIM Sirmoor. He is PhD from IIT Roorkee, MBA from IIT Kharagpur, and BTech from NIT Hamirpur. All big places, I must say. Prior to joining IIM Sirmoor, he was associated with NIT Hamirpur as lecturer for about 8.5 months. He has also worked as an assistant manager in the Department of Container Services and Marketing in Liner and Passenger Division of Shipping Corporation of India Limited. His areas of research are marketing, and if I say more precisely, he has worked in the area of destination branding. His work relates to the examination of the role of destination personality and self congruity in creating destination brands. He has published a number of articles in international journals of repute, such as Journal of Business Research, Journal of Strategic Marketing, Marketing Intelligence and Planning, Journal of Hospitality and Tourism Research, and many more. He is also a regular reviewer of tourism management, Journal of Brand Management, Journal of Travel and Tourism Marketing, current issues in tourism, etc. Lastly, I would like to thank our organizers of the FDP for giving me the opportunity to introduce the speaker of this session. Now, on behalf of the Department of Management, SMBS Jamia Hamdard, in collaboration with AICTE ATAL, I hand over the session to Dr. Vikas Kumar for an informative session ahead. Over to you, sir. Thank you.
Thank you, Komal, for introducing me, and thank you, Dr. Asad, for inviting me for taking a session on this measurement model and path analysis. So, thank you for this opportunity, and looking ahead for a interactive session with the participant. Thank you. Should I start, Dr. Asad?
Yeah, sure, sir.
Yes, sir.
Okay. Thank you very much. Okay, so. As you know, a little bit introduction about me has been given by the organizers. And to start with, as I told you that I would like to have this session as an interactive one. So before moving ahead, I would like to know that what have you understood so far in measurement model analysis, or you can say the structure equation modeling so far, because I don't know what what you have learned so far. Specifically from the structure equation modeling perspective. So let's have a little bit idea about that, and then I'll move forward. So who will tell us that what has been covered so far in as far as this structure equation modeling is concerned? Anyone?
Participants, please respond to Dr. Vikas Kumar.
Anyone can.
We have learned how to draw the model in AMOS, and yesterday we also learned how to run the model and get the output of factor loadings. Today it was only exploratory factor analysis through SPSS. So you can say some basic knowledge is already formed in using SPSS and AMOS. Like to draw the model, know where the factor is, how to formulate it, and running it.
Okay. So thank you, Saleh, for telling us that what has been covered. So I think you have the basic understanding of exploratory factor analysis, which is one part of factor analysis, and on to the different part, and specifically the confirmatory factor analysis. You know how to draw the model in AMOS, and how to analyze the data. Do you also know how to interpret the data, or you can say how to interpret the findings? Sorry, has that been covered?
A little bit what covered yesterday, a little bit, yes, like going the output and model fit, but still, I cannot say that I know everything.
Okay, great. So there is something which is remaining, and moving on. I'll start with this. What is the application of confirmatory factor analysis? Why do we use it actually? And building on that part, then I'll move on to the application part. We will take an example. Example will be taken from a book which is very well known in this particular sector. Marketing search and orientation, applied orientation by Naresh Malhotra. So we will take an example from that, so that in future, if you want to apply that example, you can get basic understanding of that example from that particular book. And the data for that is also readily available through that book, and I will also share that with the organizations, so that you can use it in the future, if you want to apply that from a learning perspective, I would say. So that we will do. So let's start with the basic conceptual understanding that why do we use this factor analysis? What is factor analysis? Then we will try to break factor analysis into exploratory factor analysis and confirmatory factor analysis. So what is your understanding of factor analysis? Why do we use it, factor analysis? Anyone in the class? See, I will not use PPT. I have PPTs. PPT, you will not get a lot of stuff. Okay, so I will try to make it an interactive session, and for that you will have to participate with me. Don't worry about that, whether you are giving a right answer or the wrong answer. Okay, so that doesn't matter to me. An attempt from your side will actually matter, and that would be vital to take this session further in a very interactive mode. Okay, so rather than writing, please participate, please speak, don't write. I don't believe in that, please.
Sir, we learned that when we have small, like a model, which is one relationship in the model, then any application can do it. But when we have so many relationships, then like across variables, so many variables,
Okay,
then factor analysis is recommended.
so many variables. Okay, so one thing which I'm gathering from from the saying of Saleh, that there are too many variables which a researcher or a practitioner or anyone would like to handle in factor analysis. Okay, I'm specifically right now on the factor analysis, then we will move on to the the confirmatory one. So number of variables are huge, rightly said Saleh. That is one of the reason to use the factor analysis. Anything else?
So,
Yeah.
so the purpose,
Yeah.
so the purpose of factor analysis is to reduce many individual items into a fewer number of dimensions, and it can be used to just it can be used to simplify the data, and to reduce the variables in regression models. I think regression
Rightly
models.
said.
Yes.
Regression I will
Yes.
not take. That is one of the application. But rightly said by Ashok ji that the main application, and along with Saleh, that there are too many variables, and we want to reduce them, and we want to find out a structure which is known as the factors later on, when we come out with the findings. Now my question, why do we do that? Why can't you handle too many variables? What is the implication or the application from the academia as well as the industry point of view that we need to reduce the number of variables? Anyone in the class?
Sir, for facilitating the analysis.
Which analysis, Komal?
Sir, if there are large number of factors, variables, then we won't be able to analyze them in a proper manner. So we need to reduce them.
Why do we? Why wouldn't be able to analyze any variables in a right manner? I would say. You are very close, Komal.
Sir,
Very close.
So much data handling is not easy, I think.
But today we have big data. We have a lot of things that can be applied on big data, be it in numbers of, be it in terms of a number of variables, or in terms of the volume of data. We can handle that.
So basically, the objective is to reduce a large number of items into few uncorrelated factors or latent variables to identify the impact or relationships between those factors.
Reena ji is very close now, one step ahead of
Sir,
Komal.
can we say for better testing of hypothesis?
Better testing, you don't know right now, that because when you are defining hypothesis from theory, you are taking certain kind of construct or certain kind of variable. Okay, if you are applying a single item scale. So the thing is that this hypothesis testing will be a part of that, but not to a larger extent. It cannot be a better explanation that why we are trying to reduce the data in case of factor analysis. Theoretical, conceptual thing is there that I want from your side. Anyone?
Sir, to understand the latent variable with minimum number of items so that we can explain the maximum variance.
Yes. Now let me explain in a very theoretical way, because Anirudh has given an answer which is somewhat technical in nature. So what is happening when you are collecting data on n number of variables? Let's say I am giving an explanation from academia point of view as well as the managerial point of view right now, and one more explanation will be there. But when we talk about the one basic explanation, that when you are collecting data on multiple variables, now there are chances that some of the variables are similar in nature. They are highly correlated one with one another. That simply means that they are trying to explain one and same thing. Okay, and that is the reason the factor analysis is used to create or develop a scale, multi-item scale. Now think about it. Okay, that what is happening, that let's say from the multi-item scale development perspective, you are doing the exercise of collecting a lot of items, a lot of questions, a lot of variables from the theory as well as from the qualitative research or from other sources, and then you have a pool of item. Okay, I'm talking right now from academic perspective now so many items are there, but you don't know. Manually you might be knowing that this set of items are very similar in nature. Now you want a statistical validation for that, and for that matter, if you conduct factor analysis which is based on the concept of correlation, you would be able to find out those items which are similar in nature. And when you will be able to find out that, and factor analysis will club those items in single factor, then the main motive of factor analysis or objective of factor analysis will be fulfilled. And those clubbing of, as I'm saying times and again, that clubbing of items in a single factor or a group will be known as a factor. And that's why factor analysis will be used. That is from the academia perspective. Now think from a managerial or industry point of view. As an organization, let's say I am the CEO of organization, some XYZ organization. I'm asking my marketing department to do a study in which I would like to know the factors, critical vital factors, which impact the loyalty of the customer towards my company or my brands. I ask my marketing department to do that. Now, marketing department, if they follow a systematic research approach, they will gather, n number of questions or items or variables to be the part of that study in the initial phase. Study to find out the critical vital factors which may have an impact on the loyalty of the consumer towards the brand of an organization for whom I am the CEO. Okay. Now, there are too many variables. Now I'm coming to the answers given by you people. You were right to a certain extent. Now there are too many variables. Now, data can be collected on that. The firm, let's assume that firm has resources to collect the data. That data has been collected through online, offline resources or mediums. And now there is a data on multiple variables, which may be the probable variables or factors impacting the loyalty of the consumer towards brands. Now, if that marketing department do a certain kind of analysis, like, you were giving answer to regression. Let's say that marketing department directly applies a regression analysis on that. Let's say, they don't have knowledge of factor analysis, that factor analysis exists. And they come out with 10 to 12 variables which are having an impact on the loyalty of the consumer towards brands. And they present that report to the CEO, which right now I am the CEO. Now, do you think that I would like that report? Do you think my organization has those, or you can say that many resources which can be applied to focus on 10 to 12 variables? It is practically not feasible. It's not feasible. So I would say, give me 2-3 important variables, or you can say the factors, then it will be a summation of certain variables. So I would be interested in that. And that's where the application of factor analysis will be very, very critical from the managerial or industry point of view. Now, what should the marketing department do? They will go back. They will have to apply the factor analysis. Factor analysis will help them to club the similar kind of variables, the variables which are similar on certain nature. And obviously, the main rationale or main, statistical measure, which is doing the background process of, clubbing the variables, is the correlation between the variables. Okay, so factor analysis is mainly based on correlation. So that will be done. And obviously, as you have done that exercise. Now, let's say those variables were around 28 to 30, let's say, hypothetically. Now, the chances are that they will automatically, organically will be reduced to 5 to 6 variables. Now, that is the one approach. The second thing is that, in factor analysis, you can also define that how many factors are required. So that can be done from your side. Based on your knowledge, your experience, your wisdom, that these many variables should be translated into so many factors. Now, when you would be applying a certain kind of regression analysis where loyalty is the dependent variable and there are 4 or 5 factors, that would make a sense. That would make a better sense compared to applying 28 to 29 or whatever, 30 variables directly on the regression analysis. So someone was quite right in the class. So that is from the managerial perspective. So that's why factor analysis is very, very critical when we have to reduce the number of variables, and those variables should be clubbed into similar kind of, into a factor which has similar kind of variables. And at the same time, you won't have to lose the essence of factor analysis by neglecting certain kind of variables manually. So this exercise will ensure that the right kind of variable will be the part of certain kind of factors. Okay, this is statistical. So that's so far so good with the factor analysis. Okay, so I think it's clear to a certain extent. Now let's talk about the confirmatory factor analysis. What is the role of confirmatory factor analysis according to you? Anyone in the class?
Sir, CFA is basically employed to confirm the factors which were identified maybe during EFA, okay, to confirm the factors that yes, these are the factors or latent variables, and these are the items that belong to that variable.
Rightly said. Anyone else? So, yes, Ale. Yeah, please.
Yes, sir. It can help us to identify or ensure that we can use this kind of scale to measure this variable if it is reliable and valid.
Nice point. So rightly said by Reena ji and Saleh that confirmatory factor analysis is doing two things for us. If you go towards the theory, it's doing actually two things for us. The first one, as said by Reena ji, that it's confirming a structure which is in terms of measurement model. It's helping us to confirm that particular structure, that whether the scale which was either earlier developed or a scale which was selected by you or adopted by you from the literature holds true in the context in which you are using that. Now the context matter here. What is context? Context means that that scale would be applied on the same population while drawing on another sample if you are developing that scale. If you have picked up that scale from certain other context, for example, that scale was developed in developed nation, for instance, that would depend. Obviously, I would say that every scale which I would be applying, let's say from a country context point of view, develop versus developing, every time that doesn't require to be verified to that extent in which in which we are trying to find out any variation in terms of culture or in terms of people's personality. That will not happen every time, but still the context is changing. The one country is there, but on top of that the time is changing. Most of the research in the social sciences is time dependent. Whatever is holding true right now might not be right 2-3 years later on. So what to do in that case? So that the solution is not of that kind that you should be developing scale every now and then for each study. No, that is not feasible. So you will have to pick up a scale from the past, and the measurement model will be a collection of those different kind of scales which you are trying to, which you are using to measure the different construct involved in that particular study. Okay. So measurement, what is measurement model? Measurement model, which we are trying to confirm in confirmatory factor analysis, is a combination of different scales, different constructs, measured through different scales. For example, your model says that the satisfaction, customer satisfaction leads to customer trust, and which further leads to customer loyalty towards brands. And at the same time, the customer satisfaction directly impact the customer loyalty towards brands. So it's a kind of a model which should be confirmed for the measurement structure, as well as the second point given by Saleh for the reliability and the validity of those constructs in this particular context. Okay, I will repeat it again. So what we are trying to do in confirmatory factor analysis, we are trying to assess whether the total model holds true in the context in which we are doing the study. Okay, and how do we do that? Little bit understanding would be there, I think, and I will talk about that when we will be applying that model. We are trying to do that with the help of different kind of, what we are using as an outcome of CFA. Anyone? What is this chi-square, or you can say ratio of chi-square and degree of freedom? CFI, NFI, for example, TLI and RMSCA. What are these?
These are model. Sorry.
Ma'am,
Yeah,
Rita, ma'am,
please.
you can continue.
These are
Goodness of fit indices,
so
basically.
these are the fit indices. Okay, and obviously some would be goodness of fit indices and some would be badness, I would say, fit indices, to check the whether the model is fitting is not fitting well. Okay, and with the help of that particular fit indices, we will say if it is not fitting well to that extent, then obviously there is something wrong in the model. Okay, so RMSCA, your SRMR, for example, these are the badness fit of indices. So you don't have to mug up these things. You just have to understand. So one thing, as Reena said, that the first objective is to find out the robustness of the measurement model, and that's what we say, goodness of fit of the measurement model with the help of these fit indices. So that is the first objective that we are trying to achieve. Okay, second thing, as Saleh said, that now we will have to check the reliability and the validity of the model. Goodness of fit is fine, whether the scales that you are using. Reena ji, please mute your mic. So the scales that you are using to measure the different construct in your measurement model, whether those scales are the right scale to be used in this particular context, research context, or not. So you would be checking the reliability and the validity of the model. Now my question to you is, what is the reliability? Anyone in the class? That should be known, basic. Please, you would be knowing, I think. Please tell that. Yeah.
Yes, sir. Reliability of the scale tells us how can we trust the scale to measure the variable again and again and again.
Yes. Anyone else who would like to add on to this? Okay.
So
Ritu is not-
reliability basically refers to the degree to the extent to which the results are reproducible. When we use the same scale on a different sample.
Rightly said, Ritu ji. Rightly said. Reena ji, sorry. Yeah. Anyone else who would like to share his understanding or her understanding about this?
Sir, how the data is reliable?
Data. Yes. Data. Okay. Consistency of measure. Okay. You people are right to a larger extent, but rather than giving a definition, let me try to help you in understanding what is this all about. Rightly said by some people. that when we are checking the reliability of an instrument, of a scale, we are checking the reliability of the scale, not of the data, remember, okay? With the help of data that is being checked, that is a different thing altogether. So when I'm checking the reliability, please don't write, it is impacting me. Please don't write anyone, please. When I'm checking the reliability of the model, and what is a model? A combination of different instruments. So obviously when we are reporting the reliability, we are reporting the reliability of different construct in that particular measurement model, if we are talking about CFA and SCM. So when I'm trying to talk about the reliability, actually I'm trying to assess the consistency of that particular scale to reproduce the similar kind of result in different context. What does it mean? That reliability is all about producing consistent results over, or you can say times again and again. What is the meaning of that? That somebody, let's say, made a scale in 2005, and that person reported the reliability and said that, you know, this scale is able to produce the result with 90% accuracy. Okay. And generally, you know, we measure the reliability of the scale with the help of Cronbach alpha. It is a single item. And for some time, you know, for multiple items, some people use Cronbach alpha. Doesn't matter. It doesn't matter. And there are different measures, but then we use in case of the CFA, the construct reliability or the composite reliability. So what we are trying to do, we are trying to say that the scale that we are using in our research context, nevertheless, it has been borrowed from the past, in which the scale was studied in different context. But when I'm reporting the Cronbach alpha, for example, or the composite reliability of this particular scale, so I'm saying that this scale is producing the similar kind of result, the consistent result in this particular research context also. And I'm not saying here that my scale should produce the Cronbach alpha value of 0.9, which was the case in, let's say, 2005. Let's say. For that, there is a threshold value as recommended by different researchers, and you know, that value is 0.7. That at least your scale, which you are using, you're adapting from the past literature, that should produce at least, that should produce the result at least 2.7% accuracy, 70% accuracy. So that is the meaning of that. And if it is above than that, pretty much fine, not an issue. But obviously, okay, so that's the thing I want to share. Otherwise, you know, it will be too much. But one more thing I would like to share with you, that if you are using your own scale, let's say you developed your own scale and you are trying to confirm that scale using CFA, you may or may not apply structured equation modeling in that case. So even the value up to 0.5 will work. Now why? Because sometime, you know, the value up to 0.5 may work because you have produced that particular scale, okay, and the reliability of that scale is dependent only upon single sample that you are using in that study. So with the passage of the time, when you would apply that scale into different context or the other, you know, researchers, then the reliability of that may or may not work, okay, but the chances are that it may increase. So sometime you can context that, even if it is 0.5, it is justifiable because this scale has been used for the first time. So that you will have to, contest with the reviewer. But I don't know up to what level the reviewer will, be ready to take that value. So obviously it will be a better idea to go up to 0.7. But sometime in some paper you will see certain items or certain scales have gone up to 0.6 or 0.55 or something like that. Okay, so that depends on other factors also. So we will not go into that because this is not a lecture on reliability. So that is fine. That second thing which you want to do with the CFA is to check the reliability as well as the validity. Now, what is validity? What is the validity of an instrument or a model? Anyone in the class?
So validity basically refers to, are we using the right type of scale to measure a particular variable or construct? No, are we
Rightly
using
said.
the right scale?
Rightly said, that whether you are using the right instrument to measure the phenomena which is of interest to you in that particular research piece. So validity is that thing, and then validity is further bifurcated into many types of validity. And specifically when we are talking about from CFA perspective, then there are different kind of validities which have been discussed in the literature. Anyone, any idea about those kind of validities?
Okay, so there are phase validity or expert validity. Then there is construct validity, which is divided into convergent and discriminant. Then there is criterion validity also, which is divided into predictive and concurrent, I think.
Rightly said. So there are different types of validities, and I would specifically talk about the validity which we are trying to measure or establish in case of CFA and SCM. So the construct validity, which is further divided into convergent validity, the discriminant validity, and sometimes some people talk about that is a nomological validity. But mostly you will talk about only the convergent and the discriminant validity, because those validities are most of the times have been or they are sufficient to establish the validity criteria for CFA. So that's why many researchers don't go for nomological validity. So even if you understand how to establish the construct validity with the help of convergent and the discriminant validity, that's fine for you. So let's talk about the convergent validity. What is convergent validity? Anyone in the class? You said that you made the model yesterday and you ran the model. So the instructor talked about these kind of validities?
Yes, sir.
Great.
Convergent is the measure that tells us the statement under each factor are highly correlated together and contributing to their concerned factor.
Anyone else who would like to attempt this?
So how strong the items converge or correlate to each other to measure a single factor or a latent variable?
Right. Yeah, Ashokji. Yeah.
So it is closely the new scale and is related to other variables and its measures to the construct of a scale, I think. Same, yes.
So if we try to explain, that what is a convergent validity. So simply when we are trying to measure the convergent validity in case of, CFA, the construct, let's say single construct, let's say satisfaction is there. So satisfaction is comprised of, let's say, 4 items. So what is the meaning of convergent validity? That each item each and every item used in that particular construct of satisfaction is actually measuring satisfaction. And when it would be established, one of the condition is the high factor loading. Now, what is factor loading? What is a factor loading? Now, I don't want definition, but how it is measured? On what basis the factor loading is calculated? Anyone?
Correlation, sir?
Correlation. Correlation, rightly said. So, if the correlation of that item to the construct is very high, so it simply signifies from the statistical point of view that yes, this item is measuring what it was intended to measure. What it was intended to measure. So it is the right item. So obviously that's why we take a cutoff of this factor loading. In case of CFA, 0.7. Sometimes we go up to 0.6, 0.5. In some cases, we go up to 0.4. And what are those cases? You will have to dig deeper. Otherwise, I will not be able to complete the structuration modeling here. Okay. But obviously, the recommended value is 0.7. Sometime, to tell you, we go up to 0.6 very safely. In some cases, not every item cases. So the simple meaning of convergent validity is that particular scale item is measuring the construct in the right manner. It is the right item to be taken in that particular construct. That is the meaning of the factor loading. Now, convergent validity. Now, how to measure that? One of the criteria is the factor loading, that it should be more than 0.7. Second criteria is, anyone in the class?
AVE should be greater than 0.5.
Rightly said, that AVE, average variance extracted, should be greater than 0.5. Now, what is the meaning of this? What is AVE?
Mean variance of the items measuring that particular construct.
Rightly said, Reena ji. Now, why it should be greater than 0.5?
Because, sir, if it is less than 0.5, then means they are not able to explain like majority of the construct.
Yes. If you remember the condition of KMO, Kaiser-Meyer-Olkin, in case of factor analysis, the threshold minimum correlation which is required is 0.5. Half of the value at least. It should explain at least half of the variance in that particular construct. And Reena ji said rightly that it is the average of the variance explained by all the items in that factor. So what can be the scenario? That sometimes some item might be explaining 0.6, let's say, and some item is explaining 0.8. That is the factor loading, and you will square that, and the variance. So when you sum the variance of each and every factor loading, it should be more than 0.5. If it is less than 0.5, that obviously the construct is measuring certain kind of variance, but it is not the right kind of value. At least the construct should explain 50% variance in that particular phenomenon. For example, if you are using satisfaction scale, to measure satisfaction in this particular context, and if it is not explaining 49%, let's say 50%, 50% of the phenomena, then this scale is not good one. You need a good, robust scale. That's why this AV condition is maintained, it's used. Third criteria for content validity.
Construct reliability should be greater than the average variance extracted.
No.
It should be greater than 0.5.
Yeah, 0.7, I would say, in case of CFA, but people go up to 0.5 also. But you should maintain 0.7, 0.6 at least. Why? See, we are doing research, we are taking this session from research perspective. Why should be there for most of the statements that you are doing? Why? What you are trying to measure through composite reliability?
So does it measure the internal consistency of
Yes, again, the same thing, that the item should be the good item. They should be producing the right, similar kind of right result. And we have talked about that. So the reliability will be the part of assessing the convergent validity, that, the scale items are the right one. We have also assessed this with the help of, the factor loading criteria, average variance extracted criteria. So similar kind of, but a little bit different criterion or criteria we are using to establish the convergent validity. Okay, so that's convergent validity done. Second is the discriminant validity. What is that?
So the extent to which a particular construct is different from other constructs.
Rightly said. Now, why it should be different from the other construct?
To avoid maybe multicollinearity or.
Okay. Anyone else?
So because if they are similar, then they are going to measure the same thing.
Yeah.
Right?
Rightly said. Rightly said that if in my model, for instance, there are three constructs, simple model, satisfaction, trust, and loyalty. If I said, please don't write on chat box, it actually, confuses me, please. So when there is no differentiation between the different construct which are being used in a particular model, then as Reena ji said, that obviously they are trying to measure the same thing. And what is the usage of that? If satisfaction construct is highly correlated or it's not different from the trust factor, let's say, the example which I gave you, then it simply means then there are similar kind of items in both the construct. And obviously the cross-loading kind of stuff will be there, but we don't talk that in case of CFA, that is in EFA. So that is a problem. Satisfaction is altogether a different concept theoretically. Trust is altogether a different factor theoretically. And obviously, when we talk about in terms of measuring that construct, that should also be different. So how similar kind of items can be there? So something is wrong with the data or the application of that particular scale through survey or something else to collect the data. That problem is there. How to rectify that? That is a different story altogether. So the all constructs should have or should meet the condition of discriminant validity, that they are quite dissimilar from one another. And how to establish that condition? There are multiple ways to do that. And the highly used method is the method suggested by Fornell and Larker. That is the one way. There are multiple ways. So even if you use the single one, Fornell and Larker method, that is satisfied. Do you have any idea about Fornell and Larker method? Anyone in the class?
Yes, sir.
Yeah, please.
It says that we should get the square root of AVE, and we should ensure that it is higher than any relevant inter-item correlation to that construct.
Rightly said. This method says there are different ways to discuss this method. That the average variance extracted of any construct in the study, in the model, should be greater than the squared correlation between any pair of the constructs. Now, what is the meaning of that? That the average, or you can say in terms of the way in which Saleh explained, that the square root of the average variance extracted should be greater than the correlation between the different set of constructs used in the item. It simply means that whatever be the whatever be the correlation value between any construct, किसी भी construct के बीच का जो भी correlation value है, that should be less than the square root of the average variance extracted for any construct. Now, what is the meaning of this? What it will tell us, that if the value of the correlation will be less than the average variance, square root of the average variance extracted, what will happen? Think from that angle.
If it is higher,
Yeah. Yes, Ale. Yeah, please.
yes, sir. If it is higher, this means that there is low correlation among constructs, and therefore they are not similar. The condition is fulfilled. But if it is higher correlation, that means there is some similarity, and we have that issue.
Rightly explained, that when we are talking about the correlation between different constructs, it should be less than the value which is being explained by that particular construct, isn't it? I should be explaining this satisfaction. Let's say I am a satisfaction construct. So I should be explaining satisfaction to a larger extent compared to the correlation of myself, that is satisfaction, with any other variable, let's say trust. That value should be less. So this is a good way of differentiating the constructs from one another through statistical measure. So that is the meaning of this discriminant validity. Okay, so that's it when we talk about CFA from the theory point of view. Okay, so now let's do the practical one, and let me share the data with you. And you have AMOS with you?
Yes, sir.
Most of the people.
Yes, sir, they have.
Great. So let's try to do this now with the help of some example, and then we will move on to the structure equation modeling. If the time permits, I will go very slowly. Otherwise, I will have to be a little bit fast. Okay. So let me share the the data with you. With whom I should share the data? Okay, this email.
Sir, I have given the email ID.
Great. I would be sharing the data with you on this. Give me some minute. Till then, you can open your AMOS. Okay. Any questions so far? You can ask any question in between, till the time I'm sending the data. Please, most welcome.
Sir, the criteria of average shared variance and maximum shared variance, does it come under formal and Larker criteria, or is it a separate criteria which is used?
It's a separate criteria. It's a separate criteria. It's a kind of range when we talk about the maximum shared variance and the this least shared variance, you can say. So it's a kind of a range of variance that is being explained by your different construct. So that is another way of finding out that which construct is is explaining what kind of variance compared to the the other ones on the higher side and the lower side. Okay, so this is the data I'm sending. Okay, anyone else? Any other question? I hope you got the data. Yeah, please. Please,
Sir,
Dibya ji.
please
yet received,
explain
sir.
the
Not yet
Foreman
received.
and Larker method once again.
Foreigner and Larker method.
Yes, sir.
Yes, sir.
Simply
Received the data.
says, yeah, it simply says that the square root of the average variance extracted by average variance extracted value of any particular construct should be greater than the correlation value between any pair of the constructs in the model. What does it mean? मान लीजिए there are 3 constructs in the model: satisfaction, again, trust, and loyalty. So let's talk from the satisfaction point of view. Satisfaction square root of average variance extracted is, let's say, 0.4. And when you take the correlation between, let's say, satisfaction and trust, satisfaction and loyalty, and trust and loyalty, so the correlation between all of these combination of pairs of different construct should be less than the the average variance extracted of satisfaction, for instance, in this case, as well as trust, as well as loyalty. So जो average variance extracted की square root value है, that should be higher, compared to the correlation between any of the pair of the constructs in that particular model. So किसी भी सारे जो मैट्रिक्स होगी, फॉर एग्जांपल, उसमें कोई भी कंस्ट्रक्ट की किसी और कंस्ट्रक्ट के साथ जो कोरिलेशन वैल्यू है वो कम होनी चाहिए compared to the square root of the average variance accepted. So you can read this formula. Don't have to mug up this. That is readily available. Okay. Or the other way, other way we put it, that the average variance extracted should be greater than the square of the correlation value between any of the constructs in the model. So एक ही बात है मैथमेटिकली, जब हम स्क्वायर रूट को हटा रहे हैं तो वहां पे हम स्क्वायर कर दे रहे हैं कोरिलेशन का. दैट सिंपली मींस, तो मोटा मोटा बात यह है कि एवरेज वेरिएंस एक्सट्रैक्टेड शुड बी ग्रेटर देन द कोरिलेशन. अब कोरिलेशन क्या है? कोरिलेशन बिटवीन डिफरेंट कंस्ट्रक्ट, सो दैट शुड बी लेस. सेटिस्फैक्शन शुड नॉट बी कोरिलेटेड हाईली टू ट्रस्ट, अदरवाइज क्या होगा? सिमिलर काइंड ऑफ कंस्ट्रक्ट है, दैट शुड नॉट बी देयर. सो एंड व्हाट इज AVE? AVE वो है जो कि वो कंस्ट्रक्ट एक्सप्लेन कर रहा है विद द हेल्प ऑफ डिफरेंट आइटम्स, डिफरेंट क्वेश्चंस. दैट शुड बी हायर all the time. Got it, Dibya?
Yes, sir. Thank you.
Okay, great. I think you got the data, everyone?
Yes, sir.
Great. Please open this data. Everyone can open in their screen this data along with me if you want to really learn. Otherwise, it's up to you. Let me share my screen. My screen is visible to you?
Yes, sir.
Yes.
Great. So I have already opened the, the AMOS, and now let's go back to the data. Let's try to understand the data first. I have PPTs, but I randomly used. Sometime or very rare I use these PPTs. So I thought the audience is interactive one. So let's go with the session in which interaction should be on the higher side. Okay, so this is the data that I have shared with you. So there are, let's go to the variable view. So now this first column name, it's giving the name of the variables. I'm not saying the construct. There is a slight difference between the variable and the construct. Construct is a combination of many variables. Okay. And what is the meaning of these items or these variables that is given here? Label. So go through this and it will give you a brief understanding of this. So what is happening here? A company, it may be a hypothetical name, with the name of HVAT. HVAT is actually trying to do a study in which they want to find out, in which the company wants to find out that how they can retain the existing employee. So actually they were facing a challenge in terms of employee retention. A lot of attrition was there in the organization. So they conducted a study on certain key constructs. For instance, job satisfaction, organization commitment, employee perceptions, and attitude towards co-workers, and finally, the staying intentions. So 5, key construct they measured. Obviously, how did these construct come into picture? Based on some secondary data analysis, same based on some qualitative research. Okay, so based on these 5 key construct that I shared with you right now, they conducted a study and they collected the data. Now, as you said, and I will ask you when the structure equational modeling will be there. So now with the help of this, they want to do some study that which are the construct which or that impact the staying intentions. Okay, so obviously because they wanted to manage the attrition rate in the organization. So for that matter, they will have to understand the key factors, the key motivation factors which actually impact the employee staying intentions. If they know those constructs, obviously they would be able to work on those and they may be able to manage the employee attrition in the organization. That's why they collected the data on these items and variables. Items, variables, questions, same kind of stuff. Okay, so I think this is clear to you. So let's talk about now this thing. Now we have to construct a model. Okay, so let me share the model that they actually promoted or they conceptualized. I remember that, but still, if I want to give you a picture of this, that what this model talks about. Okay, so let me share with you this one. Okay, now you see this, these are the 5 construct which I was talking about. Organizational commitment, job satisfaction, attitudes towards co-workers, and sorry, these were the environmental perceptions, environment in which they are working. I wrongly pronounced it as employer perception, sorry. And the 5th one is the staying intentions. Okay, so this is a CFA model because there is no relationship between these, there is no unidirectional relationship between the different constructs. That we are not trying to say that whether job satisfaction is impacting organizational commitment or organizational commitment is impacting the staying intentions. We are not saying that thing. So in CFA, confirmatory factor analysis, which is all about the measurement model, we are just trying to assess the goodness of fit of that particular model and as well as the reliability and the validity. Now let's try to do this. Let's create this model. Can you do that? So I think you know how to create the model, huh? Anyone in the class?
Yes, sir. Yesterday we learned this.
Yeah, so I will not go into this. I will directly create this model, okay, for you. So this 1, 2, 3, 4, 5. Now let's try. I don't know, I don't remember the number of items. So let's see how many items are there. So you can tell me, please note it down. Organizational commitment has 4, job satisfaction 5. Yeah, except job satisfaction, every construct has 4 items. Good. So let's go back to this. 1, 2, 3, 4. 1, 2, 3, 4. And let's say 1, 2, sorry. 2, 3, 4, 5. Let's make it 5. 1, 2, 3, 4. 1, 2, 3, 4. Now let me arrange it. Okay. Okay, great. So this is now I have to name it. So let's name it. So let's say this is job satisfaction had 5 items, huh?
Yes, sir.
Yes,
Satisfaction
sir.
has 5.
Okay, great. So let's call it as organizational commitment, ORG, and then COMM. You can name it anyway, but you just have to follow that. There shouldn't be, the values. You shouldn't be using the nomenclature, which is actually hindering the process. That's it. So you can name it as organizational commitment, ORG, COMM. Second was here the 5th one. This one is the job satisfaction. So you can say job and then S, job satisfaction. Then one is the attitude towards key workers. So I name it as ATT, towards attitude towards co-workers, ATTC. Then this is, let's say, environmental perception. Okay. And the last one is the staying intentions, let's say. Stay intention. Sorry. Name it anyway. I mean, in any manner. Sorry. So now let's load the items. So let me select the data set. Just go there, select data file. Okay, and then this one. So this is let me find out the folder first. The name is CFA SEM Hamdard. Okay. So let me go to this. Again, this one. CFA SEM. This is data. Let me open this. Okay. So, okay, this is fine. Now, let me, put these values. So let's start with the job satisfaction. This is the first item. Remember, you have to keep the item inside the box. And when that will be ensured, when the box is becoming red. When the box is becoming red, only then leave that item in that. Otherwise, the model will not run and you will find it difficult later on. So do this exercise along with me, JS3, JS4, and JS5. And then organizational commitment, OC1, OC2, OC, no, it's not. Yes, it is becoming red. No, something happened. Control Z. Let's do it again. I think something went wrong. OC1, OC2, and then OC3. If it is becoming clumsy, you can correct it. Just click on this first and just remove the variable label name. Okay. So this is, if you remove, it will be better. Okay. Okay, so fine. Because the data is stored in this way, to make you aware about the, that what this data is all about. So you can correct it also. Okay.
Sir, you can click on view interface. From there, it will automatically remove.
Oh, thank you. Okay. From view
interface properties,
yeah.
miscellaneous.
Where is
MISC,
it?
sir. Besides accessibility.
Yes. Okay.
Uncheck the display variable labels.
Oh, great. Thank you for, I didn't know this thing. Thank you so much. So now I think it will be rectified. Yes, it is rectified. Thank you so much. So now let's go with the environmental perception. EP1. This is EP1. Environmental perceptions 2. EP3. EP4. Okay, so this is done. Now the staying intentions is there. SI1, SI2, SI3, and SI4. And the last is attitude towards co-workers. So the ATT is AC. Yes, this AC1. AC1 is there. Go with this. AC2, then AC3, then AC4. Okay, so this is done. Now you have to name the unnamed variables like errors. Okay, so that can be done manually. So go to the plugins and just click on the name unobserved variables. Okay, so the error names are given in this way. Okay, so now you have to create the the covariance between these particular all the constructs between or among all the constructs. So just select the construct one by one. Okay, and then go to this plugin and then draw covariances. Okay, so the covariances will be drawn. Just a minute. This is checked, I think. Okay, this is just so draw covariances among all the construct. Okay, so this is done. So when you are studying the the measurement model, you are trying to actually assess the goodness of the fit, and that will be done when actually you will co-vary the construct with one another. All the construct you will have to co-vary. Okay, and that's why the covariance will be used. So now after doing this, simple, you know this thing. I think you just have to calculate the estimates. So before that, you go to the analysis properties and mostly keep these things checked like this, that you would be using the maximum likelihood method. Otherwise there are other methods also, so you can go deep in that if you want to study more, but mostly the maximum likelihood method is used where the model tries to maximize the variance, or you can say the variance explained by, or the covariance explained by the model. So that's why we use maximum likelihood method here. Otherwise we can go for other ones also to achieve different kind of objectives. Now go to output. Now here in the measurement model, you require this one thing, modification indices, that if something happens to the model, so then we should be able to correct that. Okay, right now we don't need indirect, direct, or total effects. You can, if you want to do some kind of moderation analysis, then critical ratio of differences may be required, so that can be clicked if you want. But squared multiple correlations are required, standardized estimates, if you want to see that on the model. Otherwise it will be depicted in the outcome. That is not an issue. Okay, so you can click on this. If you want to test for normality or outliers, that can also be done. Okay, but that should be done before this. And mostly structure equation modeling is not that much prone to normality, remember that. So it takes care of this, okay, the normality condition. If even if the data is not normal, even then the structure equation modeling will produce good kind of results. Okay, so it is not prone to that. So it is up to now CFA. So let's talk about the outcome. So I have to save the outcome. So let's go to desktop and let me save it. CFA. CFA. Okay. Now it is running. Just hold on. Great. So now just click on this, view the output and the path diagram. So you would be able to see this kind of stuff. You need the standardized estimates. So click on this. Now let's go to the output file or view text. Okay. So now, as I told you, the first objective is to check the model fit. Okay. A little bit a picture of the model is given here also in terms of the chi-square, degrees of freedom, and the probability level. Okay. Now let's go to the model fit. Now here, what are the conditions? Anyone who can tell us about the conditions? Anyone? In case of model fit, what should be the condition?
Cmin divided by df, degrees of freedom should be less than 3.
Yes.
GFI.
It can go up to 5. Let me correct you. It can go up to 5. That depends, how much data you are collecting, how much the research is difficult to do. But obviously, for the good model, it should be up to 3. Yeah, please move ahead, please.
Then, sir, GFI, AGFI should be greater than 0.95 in ideal scenarios, or above 0.9 is also acceptable.
Yes, 0.9. And sometime if the data is more, as I told you, research is unique, it's a new research. Sometimes it can also go up to 0.85. That depends the number of the data points that you're collecting and the difficulty of the research. Yeah, what else?
NFI, CFI again, 0.9, greater than 0.9.
Yes.
Then RMSEA should be less than 0.5, I think.
0.08. It should be less than 0.08 in the normal situation. But obviously, if you want a very good model, it should be less than 0.05.
Okay. I think that's it.
Yep. And then there is one more, SRMR, standardized root means residual. Okay, root mean square residual. So that value can also be calculated if you want to put, and that value should be less than 0.1. Okay. We cannot go deeper in this, otherwise we need more. Actually, if you want to cover CFA and structure equation modeling, we need at least 2 days, I think. So if we have to do this in detail, but you can read on this obviously, and do read on this and try to develop a more understanding of this. So this is as far as the model fit is concerned. So obviously it should be less than C minimum divided by degree of freedom. It should be less than 3 for good model. So it is 1.3 good model. GFI, AGFI greater than 0.9 and closer to 0.95. So it's good. CFI 0.98, very good. It should be more than 9.95. RMSCA, it should be less than 0.08. It is 0.02. So it's a good model. Okay. If it is a good model, then we will proceed for assessing the the reliability and the validity of the model. And how would that be done? For that matter, you would be going to the the estimates. Now this is the the table that you will get as the outcome of CFA. Now, how to understand this? First and foremost, you will have to see the p-value. So here all stars are there. It simply means that the estimate standardized. This is not standardized one, but even the standardized estimate is the significant is significant actually. Okay, it is less than, p-value is less than 0.001 in this case. So that's why 3 stars are there. And obviously most of the times we take alpha as or p-value cutoff p value as 0.05. So anything less than 0.05 or 0.05, that is fine with us. Okay, that value can be taken as the coefficient, okay, in the CFA. Now you don't have to take the estimates from this. Remember, you just have to take the estimate from this standardized regression weights. So you will take the estimates from this table, that is standardized regression weights, and everything else. For example, this standard error, this is the critical ratio, that you will take from this table. Okay, so you can report all these things like this, standard error and the CR. Now, for example, this OC1, there is no value for standard error and CR and P. So obviously it will be written as NA, if you want to report that as a CFA result. Okay, so if you are doing it through the AMOS, it will be written in that fashion. So this is the output of CFA. Yeah, any questions so far? So all the items can be retained in the model. That is the simple meaning of this. Okay, that the values. Now, one more thing you can check, that for example, the OC1 value is 0.583. You want to retain it or not? If you are taking the criteria as 0.7 or 0.6, obviously it will be removed. But if you are going up to 0.5, it will be retained. Okay, so if you want to remove it, it can be removed, and I'll remove it. Okay, if we are taking 0.6 as a criteria, OC1. Okay, just take this, click on this, and remove the OC1, and let's see what is happening to the model now. Obviously, the model will be more robust now. So let's talk about the output. Oh, okay. So we will have to give one. We will have to identify the model. Okay, so we have to constrain this particular parameter. So put one here and then run the model. And this is the model now. So see, now the C minimum degree divided by degree of freedom is 1.294. Earlier it was 1.3. So obviously, if some item which is low on factor loading, or you can say not factor loading, in this case standardized estimate, if that is removed, the model will improve. GFI now more than 9.95. So it will be done based on the the standardized estimate. Okay, so if it is less than 0.6, which we considered in this particular case, we will remove it. Okay, so that's it, and the estimates are like this. Now let's see, any value less than 0.6. No value is less than 0.6 here. Okay, so we can move ahead with the structuration modeling. Now my question to you is, why do we use structuration modeling? Anyone in the class? What is structuration modeling? Why do we use it? Any idea?
To assess or measure more than one relationship at the same time.
Okay, good. This is
Sir,
one
when we have n numbers of independent variables.
Okay.
And dependent variables, so then we can assess the relationship between them.
Can't you do this with the help of any other technique? Let's say there are multiple construct, satisfaction, loyalty, trust, let's say one more, attachment.
No, sir, because like normal ads, like for example, Excel or SPSS can take only one relationship at a time.
Can't we do it with the help of multiple regression?
Sir, in multiple regression, we have one dependent variable and we have a number of independent variables.
What if I will create multiple regression model?
So when we go for higher order also for mediation moderation also, then so we start with structure equation modeling only.
Mediation can also be done with the help of regression.
Sir, traditionally we have a theoretical base where we have defined the constructs, its latent variables within that constructs, and then we can associate that theoretical framework with say two or more than two variables also.
Agreed.
This is possible in structural equation modeling, but that interaction between all these variables will not be present in other tools in which we are doing them independently.
No, I don't agree. Interaction can also be taken into consideration in multiple regression. The interaction variable can be calculated with the help of multiple regression.
No, sir, not the interaction variable. The interaction within all these things, the latent variables which are under the major construct, as well as with the multiple different variables.
See. I
multiple
got it. Yeah, Anirudh. Let's say you're talking about, the satisfaction which is leading to trust, and then trust is leading to loyalty. So you are talking about interaction term between, the interaction, the common thing between the, the satisfaction and, the trust, which might be impacting the, the loyalty. Am I right?
Yes, sir, and including the structural
That
model
can
of
be
satisfaction and other
considered. That considered in multiple regression, Anirudh.
Okay.
Now, what is that which is holding me back from this multiple regression? Because when I talk about structure regression modeling, that is a combination of factor analysis as well as the regression, multiple regression. Now, what is happening so unique in structure regression modeling, which is holding me back from using multiple regression models? What will happen if I will use multiple regression model? Let's say there are 5 variables, and both, some of the variables, like in this case, are dependent as well as independent to certain variables.
Sir,
construct. Yeah.
Sir, I think we use SCM more to take care of the measurement error, along with complex relations that we normally don't account for in multiple regression.
Rightly said.
Apart from all those interactions, mediation, moderation, and complex models.
That can be handled with multiple regression.
Yes, because SPSS regression also we can do mediation, moderation using process macro.
Rightly said, Shantanu. Thank you for bringing this out. That if we use multiple regression models, the measurement model will increase. Error will increase. And this is not our objective. Our objective is to minimize the measurement error. When we talk about the research, the main objective is to measure any phenomena with utmost consistency and validity kind of stuff, and to reduce the error. Obviously, there are multiple errors, but when we talk about the application of certain technique, the measurement error and analysis error will be quite prominent. So when we use structure regression modeling, so it helps us to reduce that. It takes care of that particular measurement error. And that's why we prefer structure regression modeling. It is simple. It minimizes, it optimizes the measurement error compared to the other techniques. That is for example, in this case is a multiple regression. Okay. Having said this, now let's talk about the structure regression modeling here. Now, if you let me show you this slide now, that how did the company conceptualized this study. Okay, you can make any variable dependent or independent, but obviously when we are talking about academic and the industry research, that should be supported by theory. So let's see what's the take of the company based on the theory, logic, and as well as their wisdom and experience. So I think this screen is visible to you. Now let me open this. This one, and I think this would be there. So which model they used? Yes. This is a different model. Okay, just a minute. Okay, this is different one. Not an issue. Just a minute. Yes. Yeah. So it is clear from this. I think it is visible to you.
Yes, sir.
Great.
Yes,
so
sir.
remember now you can make this model because we would be requiring this. So what is happening in this particular model, that this environmental perceptions and the attitude towards co-workers, they are purely the exogenous construct. Okay, the independent construct, you can say. The nomenclature is altogether different, so that's why they are known as the exogenous construct. Okay, EP and AC both are impacting job satisfaction and the organizational commitment. Both are impacting. Okay, and then further this job satisfaction and organizational commitment is leading to staying intentions. Okay, so the people who are from HR, they will be in a better position to grasp this. Okay, so this is happening in this. The hypotheses are given here. The H1 is that EP is leading to JS, and so on and so forth. So there are 7 hypotheses. So let's try to make this as fast as possible. Okay, so now I just have to remove the these covariances. You can do that along with me on your screen. This technique is highly used, in most of the papers these days. Most of the papers are being published since last, I would say last or 2 decades. Most of the papers are being published. So if you know this technique, it will be handy. Okay, so now let's create first of all the the relationship. So what was happening? Environmental perception was leading to job satisfaction and organizational commitment. Yes. And then let me check again that yes, this slide. Environmental perception and attitude towards co-worker is leading to OC and JS. Great. Okay, so okay, just a minute. Where it went actually?
Sir, can
Yeah.
I access question?
Yeah, please.
Sir, the theoretical model you have shown, suppose I am also making such a theoretical model, and before going for the analysis, I made this model. Now, if I go for the same implementation, if I find that some of the these arrows and relationships which I made is not justifying after the data analysis.
Can you repeat your question? Without the theoretical support, you have made that. Am I right?
No. By theoretical support, I made it.
Okay.
But after collecting the data, if I run the same model, the links which I made from the theoretical support, it is not coming out after the data which I collected and run the same model.
Fine. Then it simply means that the theory doesn't hold true in this particular research context.
Okay.
But obviously,
yes,
if there is a strong theoretical support, and if it is not being justified in your research context, there is something wrong in terms of data collection, in terms of operationalizing those constructs from the theory, in terms of telling the research problem to the respondents. So there may be something wrong which might have happened at various steps of research process. Okay.
And sometimes it happens like that. Few of the hypotheses holds good.
Yes.
And 1 or 2 hypotheses
then the answer is that obviously that in particular research context, if you have followed a very stringent research methodology, then it simply means that the theory doesn't hold true in the research context in which you have done the research. That simply. And you have to explain that in the implication or the discussion part, that why did it not happen in that way, and what is the implication to the marketers or to the society or to the practitioner or to the academia. That you will have to explain. You will have to be very strong in terms of giving rationale for that kind of finding. Okay, then your paper will be published in a good journal.
Okay, sir. At the end, will you share some of the such papers where we can find such things?
Papers you can find. I will tell you which area you belong to.
Sir, I am doing on entrepreneurship.
Entrepreneurship. Okay, so this area is quite new.
Yes, sir. Sir, I am also mixing some of the marketing strategies also.
Okay.
How the social entrepreneurs are keeping a balance between their social mission and this social value generation perspective.
Mm-hmm.
Yes, sir.
Okay, so we'll talk about this later, huh?
Okay, sir. Okay, sir.
Otherwise, the whole class will get disturbed. Okay, so let's come back to the structurization modeling. And this is the model that we want to, find out. And one thing is remaining, just a minute. Relationship between attitude towards coworker and no. Yes, not remaining. Okay, so this is like this. 1, 2, 3, 4, 5, 6. Yeah, and let me check whether there was a relationship between organizational commitment and job satisfaction. I think there was. Okay. Yes, job satisfaction is leading to organizational commitment. Job satisfaction leads to organizational commitment. Okay, fine. Now let's play with the data. So data file is same. Great. Just a minute. What happened? Okay. And then in the property analysis properties, I also need the indirect, direct, and total effects. And that's it. Modification indices are there, not required at this stage, but still we can select it. Standardized estimates, squared multiple correlation I want, and then just run it. Okay. The following, sorry, made a mistake. Just a minute. You will have to, put an error item on the, the endogenous variable. So which are the endogenous variable here? Organizational commitment, job satisfaction, and staying intention. That is the requirement. Okay, so you will have to, because there will be a measurement error for the endogenous variable, which will be calculated based on the the impact of the exogenous variable on that endogenous variable. So that's why we have to add the error term to each endogenous variable. So just name it, go to plugin, or you can manually do that. Name unabsorbed variables and just run it. So it will run fine now, I think. Yes, it is running fine. Great. Just click on this, standardize estimates, and go to the now output. So model fit, the first task. Now, what structurization modeling is doing? First thing, it will check the goodness of fit of structure model. That is the first thing we will report in the paper also, journal article. And the second thing it will do, that it will try to test the hypothesis. Okay, it will help us to test the hypothesis. So two things are done. The checking of goodness of fit of structure model, as well as the hypothesis testing. And in hypothesis, your direct relationship can be there, indirect relationship can be there, mediation analysis, that is the indirect way of doing the the hypothesis, that can be there, moderation analysis can be there. Okay, so that is, I think, will be covered by in other sessions. So we will not touch upon that. So we'll talk about only the direct relationship here, because the hypothesis were in that form. Okay, so we will not touch upon the indirect one. Okay, the model fit, C minimum divided by degree freedom is 1.5, so it is fine. Well below point this 3 value 3. GFI 0.94, good. Then AGFI 0.92, good. CFI 0.97, good. And then RMSCA is less than 0.08, so it's good. So our model is good. So let's move on to the estimates. So now, as I said, that this table will give you the regression weight. So you will not take these regression weights. You will take the rest of the values like standard error, critical ratio, that is the the t value, p value from this particular table, and the relationship, the regression weights, the weights of the, which will tell you the how much one variable or one construct impacts the other one. So that will be taken from this particular table. So up to this, these are the 7 hypotheses that you made. That environmental perception has an impact of 0.25 on job satisfaction. And whether that is a significant effect or not, you will see from the upper table. Yes, environmental perception on job satisfaction is actually significant because the p-value is less than 0.05. Okay. Similarly, you will check for all these. Only two relationship doesn't hold true. That attitude towards co-worker doesn't lead to job satisfaction. That is the one finding in terms of not satisfying the hypothesis. Second is that job satisfaction doesn't lead to organizational commitment because the value is less than 0.05. Sorry, the value is 0.097, so it is less than 0.05. So it simply says that even if these employees are satisfied with the job, they will not be committed to the organization. It is simply stating that. So what will lead to the job satisfaction according to this model? The environmental perception, the environment, about the company culture, how the company is, treating the employee, what kind of, facilities they are giving to the employees, for instance. So you will have to dig deep in that what does this environmental perception comprise of? Okay. And then obviously, if the people are committed to the organization and satisfied with the organization, that would actually lead to the staying intention. Nevertheless, the impact is more from the organizational commitment. So it simply says that even if the the employees are satisfied, they will stay with the organization. But if they are committed to the organization, the chances are more because the p-value and even the effect, if you see, if you go through this, the effect of job satisfaction or staying intention is 0.114, which is way less than the effect of organizational commitment on staying intention, which is 0.572. So what is the finding of this model? That the company will have to make the employee committed to the organization. And if they want to make them committed to the organization, they will have to focus more on environmental perception, because the impact of environmental perception is 0.461. But also they can also work on attitude towards co-worker, whose value is 0.28. But if they have less number of resources, they have less time, they should focus more on environmental perception. Okay, they should work on that to make it perceived in a right manner by the employees. If that is done, people in that particular organization will be committed to that organization, and obviously they would like to stay for more time in that organization. So that is the the ultimate finding of this particular exercise. Now, any question you can ask me now, because 15 minutes are there. I'm there for answering the question if I know. Okay, to the fullest of my capacity, I would like to answer the questions.
Sir,
Yeah.
can you throw some light on direct and indirect effect that you have chosen while?
See, I didn't make any hypothesis on indirect effect.
Okay.
You missed out that. Okay, let me go back. Let me go back to the. I categorically said. See the hypothesis here. See this particular table. I think it is visible to you. Hypothesis, huh? So is there any indirect hypothesis? I haven't checked the mediation here, because for mediation, I will have to devote one more lecture. Okay. But mediation, for answering your question to a certain extent, if you want to check mediation, let's say job satisfaction mediate the relationship between EP and SI, for instance. For that matter, Barron and Canny method can be used. That is the simpler one, which is given in the literature. 4 conditions should be met that you can go through. Or if there is any lecture on mediation or moderation, specifically mediation in this case, so you can ask the instructor in that, or you can study for that matter. Okay. Otherwise, it takes time. It would require time to deliberate on mediation and moderation. That is not that easy. Okay. But Barron and Canny method, 1986, you can refer to. That's it, I can say. Yeah, anyone else?
Sir, so the overall model fit shows that the hypothesized, whatever we have proposed, this design, it is acceptable. But in the results at individual
No.
level,
Yeah, you complete
the
your
model
question.
fit. The model fit shows that it is acceptable, but the individual regressions, at least 2 or 3 of them get rejected. So to a layman, how do we explain this?
You got it wrong. That's why you cannot explain it. The first thing is, when I said that structure equation modeling does two things. First thing is whether the data fits well to the model or not. And the second thing, whether the hypothesis holds true or not. So when I'm talking about model, what is a model? Model is checking the fitness of the data, okay, in terms of producing certain kind of results. Whether those results are going against the hypothesized relationship or not, that is another thing. Try to understand from that perspective. For example, how do I make you understand about this? Okay, let's say there is a house, okay, and you want to buy that house. Now there are different rooms in that particular house. Let's say those rooms are the hypothesis, and the overall house, in terms of the the capacity of house to sustain the earthquake, for example, that is there. The location of the house is very good. The pricing of the house would be very good in times to come, okay, and the investor sentiments in that particular area are good, for example. But when you talk about the rooms, some of the rooms are of interest, or that those rooms suits to you according to your needs, and some of the rooms don't. And this is the similar case with many houses. What would you do? That is an example I have given from the common life. Similarly, when we talk about the structure equation modeling or the measurement model, in the measurement model, what did we do when we checked the fitness of the measurement model? We said that the model is fit in terms of fitting the data. Now, when we're talking about the fitting of the data, we are saying that yes, it is able to explain the covariance matrix, the covariance matrix. It is actually working on the covariance matrix or covariance phenomena, for example. So what is happening? The hypothesized, or you can say the expected, not hypothesized, more appropriately, the expected covariance matrix is actually fitting well to the estimated covariance matrix. Now, in layman language, what is the meaning of that? That we are saying that this model is explaining a certain phenomena, and that can be either in the that can be either in the negative way or the positive way when we talk about from the hypothesis perspective. That is the one thing from the direction perspective. Second thing is, we are taking an average holistic picture of the model, that this model actually fits the data well, but some of the relationship may or may not hold true depending upon the the answers of the respondents towards those construct questions. So even if any of your hypotheses don't hold true, still the model can be fit, because it has no relationship with the hypothesis. It is altogether a different thing which is being measured when we are checking the fitness of either structure model or the measurement model. Okay, the hypothesis actually saying that there is a relationship between one variable and the second variable, that may or may not be there. But when we are measuring the model, we are checking the fitness of the model, we are actually assessing the capacity of the model to measure each and every construct in that particular model. So that is the main thing we are doing in this structure recursion modeling. Okay, but I'm reiterating again, even if the structure model is fit, you cannot say whether any or all of your hypothesis will hold true or not, because that doesn't have any kind of relationship between the hypothesis. The hypothesis testing is done once the model is fit in terms of fitting that data, and then whether that data is talking about any relationship or not, that will be found in the next step. So that's why whether structure model is fit or is not fit, that will not guarantee you whether your hypothesis, any of the hypothesis, will be true or not. That's it from my side. Yeah, any other question?
Thank you, sir.
Thank you.
Dr. Vikas,
yeah,
as you have said, how you will decide that your data is fit for your structure modeling?
Pardon?
Say, for example, we are applying the t-test or chi-square test, whatever it is. There is 4 scale: nominal, ordinal, ratio, and interval. Okay, is there any limitations to apply this structure modeling that we
obviously this data will be interval in nature.
Okay.
This will be interval nature, and ratio can also be there, but mostly through survey and the methods that we use, that we apply in marketing research, or in any other social sciences research, that is based on mostly on the interval scale, which is very close to ratio. Obviously the 0 point is not there, but still it is the replica of the data, the continuous data that we want to use. So interval data will be required for this.
Thank you.
Yeah. Anyone else? Great. So it was a good experience to interact with you people, good audience, and thank you. And if you have any further question, you can contact the organizers as well as me. You can take my email IDs or contact number from them, so then we can see what can be done in your case. Someone was asking questions specific to his thesis or his research. Yeah, you can ask that question. Is there?
Yes, sir. Actually, when I was just going through that process, I was finding that 2 or 3 of my hypotheses was not satisfying with the model.
Not an issue. Not an issue. Dattaji, I would say here that if your hypotheses are not holding true in any scenario, that is a quite interesting finding, isn't it? It's a new thing you have found, na? Why are you worried about that? You just have to explain that why did it happen, and how it can be, now explained to the reviewers. And something is happening in the past, and you are again, proving that thing. There is nothing new. Obviously, the context is different. But if something is not coming out in that direction, not in line with the previous finding, give a strong rationale for that finding, and then you sell like anything. It's a good thing.
Thank you, sir. Thank you.
Yeah. Anyone else? Okay, great. So thank you very much, and hope to see you at some other platform some way or another in nearby future. Thank you. Thank you so much.
Komal, please conclude the session.
Yes, sir. Conclusion. On behalf of everyone here, I thank Dr. Vikas Kumar for a very informative session. I'm sure we all have gained a lot from this valuable session and the most interactive session so far, I must say. Now, all the participants are requested to fill the feedback form, and the link for the same will be provided shortly in the chat box. Now we will meet for the third session of the day at 2:30 p.m. Thank you. Thank you, everyone.
Okay, thank you, Komal. Thank you, Asadji, and thank you, everyone.
Thanks a lot, sir.
Thank you, Vikas.
Thank you, sir.
Thank you. Bye-bye. Take care. Thank you.
Take care.